Hello everyone, here I am presenting you an illustrative example to look at the centroid of a composite area made of elemental areas with known centroids such as triangle, rectangle, square and circle. I'll focus on two important techniques. First, taking advantage of the symmetry to directly locate the centroid, and second, finding the location of the centroid when it is not possible to take advantage of the symmetry. In this example, we are interested in locating centroid of this composite area. To measure the distance to the centroid, we need reference axis. The reference axis can be anywhere at a known distance from the object. Arbitrarily, let's take the reference axis x and y with origin at the lower left corner. The object is symmetric about the central vertical axis, the dashed line. So the centroid must be anywhere along the vertical axis of the symmetry is marked by the red dot. Since the vertical axis of symmetry is 6 inches away from the y-axis, xc is 6 inches. But the object is not symmetric about any horizontal axis, so yc is not known. The centroid can be at any distance from the axis. This means we need to do some math to get the location of the centroid measured from the x-axis, that is, yc is unknown. We will find y sub c by dividing the object into elemental areas, of which we know the centroids, in this case triangle and rectangle. Let's consider the bottom rectangle as element 1, middle rectangle as element 2, and the top triangle as element 3. Based on these three elements, the location of the centroid of the whole composite area measured from the x-axis is given by this formula. Okay, this formula looks a little complicated. Let's take a look at each element one by one. This is the bottom rectangle, that is element 1 of the composite area. The area of this rectangle is 36 square inch. Since we are going to find y sub c, the distance to the centroid of this element 1 measured from the x-axis, y sub c1 is half of its height, which is equal to 1.5 inch. Now plugging these values in the equation of y sub c, we get this, which is not complete yet. This is the central rectangle, that is element 2 of the composite area. The area of this rectangle is 54 square inch. Again, since we are going to find y sub c, the distance to the centroid of this element 2 measured from the x-axis, y sub c2 is 3 plus half of its height, which is equal to 7.5 inch. Now plugging these values again in the equation of y sub c, we get this, which is still not complete. This is the triangle on the top, that is element 3 of the composite area. The area of this triangle is 9 square inch. Again, since we are going to find y sub c, the distance to the centroid of this element 3 measured from the x-axis, y sub c3, is 3 inch plus 9 inch plus 1/3 of the height of the triangle, which is equal to 13 inch. Now plugging these values in the equation of yc, we get 5.8 inch, which is the distance to the centroid of the composite area measured from the x-axis. So finally we found that the centroid of the composite area is located at 6 inches from the y-axis, that is xc is 6 inches due to symmetry, and 5.8 inches from the x-axis, that is yc is 5.8 inches. Okay, I hope you understood the basics on finding the location of the centroid of a composite area. Please let me know if you have any questions.